All right, so did you get 242? Now, what would be the units? Look back in the problem, and what is M of T?
People per hour?
Yeah, this is people per hour. So, at what rate are visitors entering the Met at 11 a.m.? 242 people per hour at 11. So, how many people have entered the Met between 10 a.m. and noon? So, how might we do this? And I'd like us to be using calculus here. Yeah, Quinn?
Do the integral from 10 a.m. to noon.
Good job. Yeah, you're going to do the integral. So from 10 a.m. to noon would be from 0 to 2 of m of t dt. Go ahead, and for time's sake, let's do this on the calculator. So let's practice that skill. And on the AP exam, it would be perfectly acceptable as work to do 0 to 2 m of t dt. Like that would be, if this were calculator, that is sufficient because they know what m of t is. Yeah. I don't know yet because it's not done. I'm pretty sure it's going to be mostly calculator because we've been doing our calculator. So it could have two parts, or I could just say it's all calculator. I haven't decided quite yet, but good question. All right, are you getting 456? Now, what would the units be if I'm doing an integral? People. Good job. And the question sort of helps you there. It says how many people have entered. So then in letter C, between 10 a.m. and 4 p.m., at what rate do people enter the Met on average? On average. So this is going to be 1 over 6 minus 0, the integral, from 0 to 6 of m of t dt. Again, let's go ahead and do this on our calculators.
So if you were doing it by calculator, would you need that second part to get full credit for now?
No, it still would be okay. The 1 over 6 minus 0 or 1/6 out front. Either of those would be okay. Now, this is a rate. So when you're asked for an average rate or average value, then notice my units change. So I'm getting 396 people per hour. Did you get that? All right, awesome. So we're learning and practicing how to use those calculators. All right, number 2, and this is what's cool about that packet I had you work on Friday, and I forget what it was, the people entering and leaving. Okay, that's what this section was all about, so I was planting seeds for this particular lesson. Number 2 says people leave the Met at a rate of L of t equals negative 90 plus 4,800 over t squared minus 14t plus 55. Now, do you notice that the time is 0 to 10? Why is this 0 to 10 and not 0 to 9.5? Yeah, Ryan?
Because people aren't allowed to stay till I think, what is it, 8 p.m.?
Yes, the people can stay till 8 o'clock, so they can be leaving the entire time. Is the number of visitors at the Met increasing or decreasing at 2 p.m.? And how do you know? Well, L of t is a rate, M of t is a rate. So what would t be at 2 p.m.? 4. So what we're going to do is we're going to go find L of 4 and M of 4 and compare them, because these are the rates at 2 p.m. or after 4 hours.
Could you also do like the integral of M of t minus L of t to find the same thing? Or
That's not going to give me a rate. That's going to give me number of people.
no?
Yeah, good question though. But you're on to something a little later. We will end up with an integral for something. All right, for leaving, I had 230 people per hour, and M of 4 is people entering, is 512 people per hour. So then what would you say? Yeah, Ryan?
I have a question. So for the L of 4 equals 230, can I just say negative 230 in like the context of this problem, or does it not really matter?
Did the calculator spit out negative
No,
230?
it's
So
like 230.
no, because that represents number of people leaving. So if you said negative, then that would be positive. Like that would be entering. You know what I mean? If you made a negative leaving.
Yeah, I was thinking of it in the context of like just how many people go in, or
No, yeah. So if L is stated to be the rate at which people are leaving, then you're not going to put a negative because it already represents leaving. That would be like a double negative. Okay. All right. So, is the number of visitors at the Met increasing or decreasing at 2 p.m.?
Increasing,
It's increasing, and how do you know?
because there are more people entering than leaving.
It's increasing because the rate that people enter the Met is greater than the rate that people are leaving the Met. All right, then number 3. When is the number of people at the Met at a maximum? Well, the number of people is at a maximum when the number of people entering minus the number of people leaving, that rate, changes from positive to negative. So you could do this one of two ways, and it has to be done on the calculator. So do you know how to store a function on the graphing calculator? Do you know how to do that? Let me grab one. Because as we get into more complicated problems, it's going to be beneficial to be able to store functions. All right. Okay, so let me see if I can do this right. Okay. Okay, so what you're going to do is you could type in whatever that m of t is. So let me show you this, okay? So what you would do is you're going to type on the calculator 2t cubed minus 48t squared plus 288t. And then on the calculator, there is a button above the 9. And what you're going to do is you're going to hit the control key and then the button that says bar. And that's actually the store key. And then you're going to type m of t with a parenthesis, okay? And it should say done. Then we're going to do the same thing with L of t, and you're going to have to be really careful. Now I think on your calculator it'll put this as the denominator. If it does, then don't worry about that. L of t. So do this on your calculators, okay? So let me go over how to store a function. So you just type it in, you hit the control button and bar, that's store, and then you have to name it with a function notation. So you're going to call it m parenthesis t, the same t that you used. Okay, then what you're going to want to do is add a page, and you should be able to type in m of t minus L of t. That's one option. Or, okay, so one option is to type in m of t minus L of t and look for that x-intercept. Another option is to enter two graphs. Enter m of t and L of t and look for the point of intersection. That does the same job. I think it's easier to do. So add a page, okay, add a page. And you're going to graph m of t minus L of t. And look for the x-intercept. Let's see if this works for us. I got t equals 5.399. Are you getting it? Anybody there yet? I know you're still working. But this is an important calculator skill that we'll keep practicing it until May 8th so that you can learn how to store. And so do you notice if you're able to look at the graph, this is where the graph changes from positive to negative, and that's a relative maximum. All right, questions? Are we getting it on the calculator? It's really important that we get comfortable and confident with using the graphing calculator. So if I wanted to say like what time that was, I think t equals 5.399 is just fine. How do you know? I think we have it explained there. The number of people is at a maximum when m of t minus l of t changes from positive to negative. All right, then number 4. At t equals 0, there are 25 people in the Met. How many people are in the Met at the official closing time at 8 p.m.? So I'm going to pause a moment and I want you to think about this. Think about what integrals represent. Think about the times where people are entering, the times when people are leaving. They're not necessarily all of the same times. So let's see if somebody can come up with an integral or integrals expression with that initial amount.
Right, that people entered at like t equals 7 to say that t equals 9.5 because you can't have any more people entering.
Nope. Okay. Nope, so you got to account for that. It's a good question, good thinking. All right, Brian, can you tell us what you wrote down? Because you did it beautifully there.
25 plus the integral from 0 to 9.5 of m of t minus the integral from 0 to 10 of L of t.
Good job. Okay. So do you see people are entering from 0 to 9.5, but they can leave from 0 to 10. So I have to account for that. Now, so here it is. You're going to do your initial plus your accumulation is going to equal the final amount. And watch out for domains. They love to do this on the AP exam, okay, where students are going to do one integral and they're going to go 0 to 10 m of t minus L of t and get the problem wrong. So now here's the beauty of what we did, and we should have done this at the get-go, but better late than never. So now watch what you can do. If you have stored m of t, okay, if you have stored m of t, guess what? You can type this straight across, 25 plus, do your menu, calculus, numerical integral, do 0 to 9.5 m of t dt, plus or minus the integral 0 to 10 L of t dt. You can use the stored function now instead of typing the whole thing in repeatedly. Okay? That'll make your life a whole lot easier on calculator portions. So let me pause a moment and let you get that typed into your calculators. See if there's one with the yellow sticker.
I have one, it's charged.
Oh, okay. And you don't have your calculator? Okay, you can borrow one that has a yellow Mac Money sticker on the back. Because you want to be practicing. Plug yours in. There should be 2 in the very back that have a yellow sticker on it. Are you getting 120.68-ish? Okay, and that's in people. They're probably going to say to the nearest whole person, so we would probably say 121 people, because you know you can't have 0.68 of a person, I hope. All right. Are you getting it on the calculator? Like, are we able to enter this? Okay, good, 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 good. Yay. So it's really, really, really important that you're able to use the store feature. It'll make you more efficient, okay? It'll make you a lot more efficient. All right, so what are the important ideas? All right, so let's call a quantity y of t and its rate of change y prime of t. I've got three big ideas here. The first one is the integral from a to b of y prime of t dt, is fundamental theorem of calculus y of b minus y of a. This is the integral of a rate of change is equal to the net change in quantity. And we've seen this multiple times, okay? That's not anything new. So the integral from a to b of y prime of t dt equals the quantity at b minus the quantity at a. So that's the integral of a rate of change equals the net change in quantity. The second idea is the accumulation equation. And that's y of t equals y of a plus the integral from a to t of y prime of x dx. So if I want to get to wherever t is, I take the initial amount plus that net change. The third thing is sometimes y prime of t consists of a rate in and a rate out. So on your calculator, if you let y1 be your rate in, y2 be the rate out, then y3 is y1 minus y2. All right, so let me give you about 5 minutes, and I want you to try the check your understanding. There are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph shows the rate R of t at which people arrive at the rate throughout the day. Time is measured in hours from the time the ride begins operation. So letter A says how many people arrive at the ride between t equals 0 and t equals 3. So you have a graph this time. So the first one we looked at, we had an equation. Now we have a graph. So make connections and see how you figure out how many people arrive at the ride between t equals 0 and t equals 3. This is not asking me how many people are there at hour 3. This is the rate of change. This is not, so that is not the number of people in line. Okay? Yeah, I think that's what you're thinking. The graph is R of t, the rate at which people arrive at the rate throughout the day. And try to show calculus, like what would this be representative of? The integral is the area under the curve, right? It's the area under the curve. All right, so if you're struggling on letter A, oh, and Quinn, it's not R prime of t. R of t is a rate. So it's the integral from 0 to 3 of R of t dt. So isn't that integral is the area under the curve? Yeah, there you go. So I cut this into 2 trapezoids to do that. So I have 1/2, my height is 2, and then I have 1,000 plus 1,200 plus 1/2. Now the height is 1, and that's 1,200 plus 800. So for part A, you should be getting 3,200 people have arrived. So you don't do anything with the initial 700 people. It's not asking me how many people are in line, how many people arrived between time t equals 0 and t equals 3. So you're not using the initial amount yet. How many people got there? All right. It's only about half of you. All right. So letter B, is the number of people waiting to get on the ride increasing or decreasing between t equals 2 and t equals 3? And I think a lot of you are going to get this wrong. Anybody feel confident about your answer?
You had subtract something from 800.
It has something to do with, that while there is a line, people move onto the ride at a rate of 800 people per hour. So do you see at time is 2, there's 1,200 people, and at 3 is 800, but this does not include the 3. So between the 2 and the 3, there's more people getting in the line than getting on the ride, right? So it's increasing. Oops, I think I said that backwards. It's increasing because the rate at which they arrive is greater than the rate at which they get on the ride.
Do you even have to like evaluate the like? Can you just like look at the graph and see like in that interval the slope is negative, so it would have to be like increasing because your rate like going in is positive, so then it would have to be positive since the rate is negative.
Yeah, you could say that. And you just have to be able to explain that then. So R of t is bigger than 800 between 2 and 3. Notice it doesn't say or equal to 3. So again, the number of people waiting in line, waiting to get on the ride, is increasing because the rate at which they arrive is greater than the rate at which they get on the ride. And it's a constant rate, people getting onto the ride at a rate of 800 people per hour. So in letter C, at what time is the line for the ride the longest? Well, the number of people in line is at a max when the rate of change of the line changes from positive to negative. So that's R of t minus 800 equals 0. Or you could determine when R of t equals 800. And we can tell from the graph that's t equals 3. And we know R of t was greater than 800 for 0 to t. And R of t less than 800 for t greater than 3. So that's going to be your maximum. Now, if you want to figure out how many people are in line at t equals 3, you're going to take the 700 plus the rate of change was 3,200, which we got in part A. And then how many people are getting online? There's 800 people every hour. So there's 1,500 people in line at t equals 3. So let me go over the blue part one more time. So when the park opens, there's 700 people, right? Then there's a net change of people arriving, and we figured that out in part A to be 3,200. But at the same time, every hour, 800 people are getting on the ride. So that's a takeaway for a total of 1,500 people. Oh, so you can see Kings Island. You can be doing some math while you're in the lines. All right, letter D. Write but do not solve an equation involving an integral expression of r whose solutions gives the earliest times t at which there is no longer a line for the ride. Well, you'd have 700 plus the integral from 0 to t of r of x dx equals 800t.
Wouldn't that give you the initial value for the function? Because you're doing the initial value plus the numerator.
No, I want to know, so on the left side, that's going to give me how many people are in line, okay? The left side is giving me how many people are in line, because this is the initial plus the change from 0 to whatever time I went.
Okay, so at the end, it'll be like how many people are at the end. Okay.
Yeah, and then the right side is how many people were getting on the ride, okay? So they're no longer in the line,
Okay.
and I want to know at what point would those be equal.
Oh, so then you just have to plug in times to see.
Yes, yeah.
So if you just wrote as minus 800t on the left side, would that be the same thing? Because
Yes, yeah, great question. So he said, could you have the minus 800t on the left equal 0? Absolutely.